Hey everyone, welcome back. Today we're going to look at a review of sine, cos, and tan. So for this lesson, set your calculator to degree mode. And for more details on this lesson, check out these grade 10 videos. Intro to sine, cos, tan, solving right triangles, and SOHCAHTOA origins. So a unit circle on a Cartesian plane. This is a circle with radius 1. And each point on the circle has an x component and a y component. The angle theta is from the positive x-axis counterclockwise to be a positive angle, as we saw before. So here at angle theta, the y value on the unit circle is sine of theta, and then the x value is cos of theta. And then we define tan of theta to be sine over cos, right? So this is y over x, so this is a slope. So sine, cos, and tan are functions. So we say sine of theta, cosine of theta, tan of theta, like that. So an example here, sine of 30 equals 0.5. What this means is that on the unit circle at angle 30 degrees, the y value is 0.5. Okay, here we have another example where we have cos of theta equals 0.423, and we want to solve for theta. So we go cos inverse to both sides. These cancel out. So we have theta equals cos inverse of 0.423. Punch that in your calculator and you get 64.96 degrees. So from similar triangles, we get SOHCAHTOA. These are for right angled triangles. So sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent, like that. All right, so back on a circle here where we have a certain point P, x comma y. The radius is r, and so we notice that we have x squared plus y squared equals r squared, like that. So we can isolate r to be root x squared plus y squared. Sine of theta, opposite over hypotenuse, so y over r. Cos of theta, adjacent over hypotenuse, so x over r. And then tan, y over x, like that. And that's it. It's that easy. I'll see you guys in the next lesson.